Vaselin.
Ja. OK. Pling, pling, pling. Nå starter vi igjen. Ja, OK. Takk for mange fine refleksjoner rundt nytt direktiv. Og bare fyll gjerne ut det skjemaet, og ikke minst, hvis det er noe dere lurer på, så ta gjerne kontakt med oss. Ja, vi vil gjerne høre fra dere. Og nå er det neste presentasjon som I will switch to English, so Vasilis knows what I'm saying. Yep. So this is the last presentation before lunch. And we always love it when people contact us and say we have something we want to say to the BBF people. And this happened this time, so Susanne and Vasilis is going to have a presentation together now about the microsensors, which is a very interesting theme. So with that, I'll just give the word to you guys.
Thank you. Yes, the title of the presentation in the program is Mikrosensorprosjekter, hva har vi lært? And as Line said, we will have it in English since we are cooperating, Vasilis and I. So it's basically what have we learned from all the projects we have had with low-cost sensors. And I would also, this is not only from the municipal side, it's not only me who has worked with this, but we have had cooperation with especially Kristiansand and Bergen municipality. Which I will want to give the credit to, but also we have had also other cooperations with other municipalities like Drammen, especially, and Bærum throughout the years. So this is basically because we have, this is many years ago, we started to look at this when this was kind of a little bit more upcoming issue. We started to look at this low-cost sensor thing. So why did we want to explore this? You can ask. So the main one thing that happened during that time was I will start at the bottom. This experience with sensors. We realized that especially other places in Europe, there were growing private initiatives using low-cost sensors, and low-cost sensor networks were developing. And these low-cost sensor networks suddenly were kind of in working in a way against the official monitoring networks, and we thought we don't want that. Like the private people were saying, oh, our sensors are showing this, and the official networks are saying, oh, our monitoring sites are showing this. And so we wanted to get our own experience and knowledge about sensors, kind of so that we don't. We didn't want to have this argumentation with the public, but we wanted to more cooperate and work together on this. So, but then, of course, we also saw many positive things with these low-cost sensors. Basically, they were cheap. So, the main question was, could these sensors actually help us to get cheaper and more monitoring data at the same time? To, for example, get a better overview generally in the cities, because there are many local variations, like Bergen is a good example for that. You have these, the population models are not really working well everywhere and so on. So maybe we can get a better overview locally. More local information on construction sites, industry, wood burning, and even some road sites and so on. Also maybe some more overview for urban planning. Better information on that. Could we give some more information to better information to the public? We know that nowadays people want to know how everything is, and especially, like, for example, air quality is where they are right now. Could we maybe do something like that? Also, politicians ask questions on certain areas, maybe something we could use sensors to explore that. And also we have a lot of measures that we're carrying out, abatement measures, but also other measures like closing roads or so on. Can we use sensors to see the effect of that? And also, is there any way we can combine sensor data with other monitoring data and also other models, traffic data, and so on? So, and then we also had some practical question, like what is actually the total cost over time, and are these sensors actually so cheap as they are, as they say they are? Do they actually not need maintenance? Can we use a single sensor, or how many sensors do we actually need? And who should work with these sensor networks? Should it be like the municipalities? Should it be a research institute? Should it be people, citizens? And what about the data quality and also data quality assurance and control? So many questions. So what did we do? We have experience from quite some research projects. We've not been the main ones that we as Oslo municipality have been involved in is Urbanity and IFLink, but there are also other projects that are interrelated and that other municipalities have been involved in. So we had some research projects which included many different cities and also different types of sensors. Now I'm focusing on the air quality sensors, but from different suppliers, but also we have tested traffic sensors and other sensors. And also monitoring different components like especially PM, but also NO2 and SO2 has been tested, and there have also been several different approaches. And I will just shortly say a little bit more about that. In some cases, the sensors were used as part of like a smart cities project, which was very in like maybe 5 years ago or so. Like you have a lot of sensors in all the city, and then you see what you get. And also not only air quality sensors, but maybe also noise and traffic and combining data, this big data thing that several cities here, I think, remember. And then in other cases, we try to deploy sensors in city development areas, like Bærum did this, for example, in Fornebu, to see how air quality was in these areas. Then we also had some focus on wood burning areas. Kristiansand was very big on that, and industry also mainly in Kristiansand, as I am aware of at least. And then Oslo, as you see on the graph below, had the sensor network basically trying to cover the whole city or the most part of the city where it was relevant. And also we have had some testing with the effective measures. Like we have, this is also from Oslo. This is in Grønland for those who are, no, now I don't have my glasses, but this is actually, this road is called Grønland. And I think. And it was closed for traffic, for the regular traffic. And then we placed some sensors in this area. And it was actually both air quality and traffic sensors just to try to see if we can see the changes in both traffic and air quality from this. But during all these sensor projects and all these different deployments, we've made some experiences and met some issues. For the first thing, if you're a municipality and you are supposed to buy at least a lot of sensors, then you have issues with tendering and all these things, and also making good specifications. Now, there have come some technical standards for sensors, which are still challenging, but they still at least give a basis on what you should ask for. But at that time, when we started, it didn't exist. So just this to buy the right sensor can be challenging, and also to evaluate if what they promise is actually what they can deliver is a challenge. Then we also have the sensor installation. There you can, as I already mentioned, you can have citizen science projects, which we've had some, and they have their advantages and disadvantages, or you can have more like official networks, and they also have advantages and disadvantages. And then you have also all this on responsibility for the sensors, and everything with the sensors and the works and agreements that you have to think about. The maintenance and the sustainability of the sensors, and then everything that has to do with the data. You have data security, data quality, data processing, which is actually quite complex. If you have like 50 sensors, as we saw in Oslo, for example, you get a huge amount of data, which you have to in some way process and have some control on. And then basically this also led us to some ideas about the total cost, and if the low-cost sensor might not actually be so low cost in the end. And a lot of what I've just mentioned, and also what I'm mentioning now, is we have, especially the municipalities of Bergen, Kristiansand, and Oslo, have worked on a document, which is like basically a guidance document for other municipalities, which we will publish within this year, which is kind of a result from this project Urbanity, which is now finishing. Which is based on all of our experience, which we hope that can help also many of you other municipalities, and at least give you some insights on what we've experienced. It's, as I said, based on our experience, so there might be other sensors and other things that that others have experienced, but we've worked with this for a while, and we think that this knowledge that we've collected should be shared. So what are the challenges and the possibilities in the end? Is the sensor data useful, and what for? Yeah, that you can ask. Definitely it can be used for citizen science, which we will also see an example for later on, and creating awareness. Then we've also seen good examples, especially from Kristiansand, which was maybe not actually intended, but using the sensors which we have used for wood burning, has been quite successful. And we will also, this will be an example that Vasilis is showing afterward. But they can also maybe use for, we have also used them a little bit, or not we, but Kristiansand has also had a look at using them for industry. They do not give you exact values, but they can give you, for example, information on the peaks, and that might be useful if you use it in the right way. But then we have the city planning, and actually also the construction sites and the dilemmas there. The sensors we have had experience with, they have not monitored PM10. And that's the main issue for us, and especially in these cases often in construction sites, and also maybe and for many municipalities in Norway, which, as we have discussed earlier, PM10 is a really big issue. And not being able to monitor PM10 is the challenge when you want to monitor these things. On the other hand, planning authorities might want to monitor what they're supposed to do, and there are criteria to showing or to monitoring around construction sites, and so we have to be aware of what can be used and what we should not use of monitoring equipment to get the right data in these cases. Then we've also this effective measures is very difficult, but if you but they can be used for information and communication, and also maybe for the effective measures, but especially when you combine data. But the main point is that it should be fit for purpose. You actually should know what you want to discover, and then find the right monitoring equipment to do it with. And maybe for the challenge that you have, there might not be a really cheap version as you were hoping for, but maybe you have to buy something else and do something else. But for the fit for purpose, Vasilis will have a good example, I hope, from the Oslo Bedre Byluft.
Okay, thank you, Susanne. So yes, we will discuss about the Oslo Bedre Byluft. So we are focusing on this area, and especially in Bærum and the western part of Oslo. And the fit for purpose for us, it is monitoring wood burning, as it is one of the main sources in particulate matter. The study area includes detached houses with fireplaces and wood stoves, which strongly affect local air quality conditions. And also the number of reference sites is limited, since we have 3 reference sites in this area. So why we are discovering this area because models show different PM2.5 values in Oslo and Bærum. And for solving this problem, because we cannot find any good explanation about how the model show these discrepancies between Oslo and Bærum, we want more local data in the areas that we are not monitoring the air quality and especially PM2.5. So a part of the solution, as Susanna mentioned in her presentation, is to involve citizens in the monitoring activity. So it is a citizen science activity. So here I give the credit to my colleague Torleif Weidel for this map. We can see that the models are measuring differently in Oslo and Bærum. And also I need to mention that in the source apportionment procedure that they conducted, they found that 50% of 50% of the PM2.5 is attributed to wood burning activities, even also for the traffic sites like Hjørtnes in Oslo and Hjørvik Station, their traffic sites, but 20% of the PM2.5 is attributed to traffic, 50% to wood burning. So with this Oslo Bærum BiLab, we are not working as Nilu or as Oslo and Bærum municipalities. We are collaborating across different stakeholders. We have Oslo and Bærum municipalities since the target area are these two areas, and also we have this thematic focus on measuring wood burning through these microsensors. We have some joint activities like workshops between Nilu and the municipalities, but also Nilu and the municipalities and the other stakeholders. We're collaborating with NAF and Bidels of Fuller and Vestracker. They helped us to gain, to spread the word, so we are more visible through these two associations. And also the most important part are the wells and the citizens, since they are helping us to monitor PM2.5 with low-cost sensors. So they have adopted the sensor and they are measuring. Also, they are participating in the workshop, so we can gain their feedback and their concerns through the joint workshops that we are having. And also, the most important is that through participating in all these two activities, they are bit more local awareness about air quality in their area. So we have installed, I have in my slide 20 low-cost sensors, but we have more. We have more or less 30 because this week and next week we keep installing sensors in this area. Now I can say we have 9 in Bærum, but they are 11, and 13 in Oslo. And of course, I mentioned that we are still installing sensors. The measuring period was January 2025 to winter 2027. So we were a bit late for installing the sensor the previous winter, so we started late in January 2025. And also you can track the PM2.5 measurements using this website in near real time, so each citizen can see the data that the citizen collects, but also he can track, let's say, the PM2.5 concentration in the neighboring areas. But discussing about the air quality, we are applying all the good practices for quality control the data. We have developed at Nilu a procedure for quality control the air quality measurements, but also we have collocated 3 sensors in Sofienbergparken. We can see that the sensors overestimate the reference measurements under high humidity conditions, and especially after 80, no, it is not the best, after 85% of relative humidity, but we are correcting the data, and finally, after the correction, we can see that we have a good agreement between the reference and the sensor measurements. This data is the daily average and colored by the air quality index from January 2025 till November 2025. We can see a lot of gaps in the data. it is a citizen science project, so we are expecting these gaps. For example, if we have installed some sensors in the participants' places, like let's say here, we need to contact the citizen to go at this place or to contact more than once, and then it needs follow-up communication with the citizens to reset the sensor, or if they are not available, we need to go there, or we need to replace the sensor if it doesn't work. But in general, the air quality, as you know, it is good in this area, but we have some accidents. No, some accidents have some higher values during the winter period or during the cold days. Here. Okay, it is another example on how we can visualize the data. So it is a daily PM2.5 comparison with the 25 and 15 micrograms per cubic meter. And we have the reference in Beckes-Tua, Hervik, Station, and Skoyen, and also we have the sensor data. As we can see, we don't have accidences, a lot of accidences. We have some cases that some sensors are showing values higher than 25 micrograms per cubic meter, but the number is limited, I can say. And regarding wood burning, here we can see in the upper panel the general distribution of the PM2.5 concentration from the sensors, and here the lower panel from the reference. And also we can see that in January, February, and March 2025, okay, it shows a typical urban profile, but in the evening and late afternoon, evening, and night time hours, we can see the higher concentration, both measured by the sensors and, of course, from the reference. So we can see that we can understand the pattern showing the PM2.5 values from the references. This is another example for last week. And we could see that we had high concentrations from the three reference sites. Of course, we can analyze the data from the other reference sites in Oslo, like Sirkeveien or Smestad. But even for these three sites, we can see some higher peaks on the 15th and 16th of December. And we can also say that we can track these peaks with we are following the same pattern with sensor data. Now, the way forward is that, of course, we need to do our best to keep the sensor network operative to provide local PM2.5 values. And we need to analyze the collected data not on a seasonal basis, but also to check in a daily basis, and or when we have high PM2.5 levels. The other option is to assimilate data into air quality models. We have worked on this in the past, and we keep working on this now. And the most important is that we need to gather feedback from the municipalities and the citizens through joint workshops. So we are continuing our activities because I am mentioning again that it is a citizen science project. And also the most important is to raise awareness by promoting the B-Labs activities and the results, and also to discuss with the citizens the data that they are measuring, how their data want to visualize, and also what we are missing through our approach, and what do we need to improve. Concluding, the sensor can't be used as supplement monitoring, as a supplement to monitor and modeling PM2.5. This is an example. In the upper panel, we can see the background is a UMF model, and we have some concentration from the reference and the sensors. The dots are the sensors. And after assimilating our sensor data in this model, we can see some difference, especially in the areas that we lack monitoring. Especially, for example, here you can see that it turns from blue to yellow, or in this part that you can see the red values following in this road. So the most important part is that we can use sensors, but as Susanna mentioned, is fit for purpose. And also we are waiting for your document when it is ready this month. Okay, thank you for your attention, and I'm sorry for my English. Okay, next time in Norwegian, I promise.
Well, thanks a lot, and great that you come and share your experiences with us. It's very exciting to see, and I'm looking forward to the report. I think that's going to be interesting for a lot of others. For example, other municipalities that wants to, look into this. And I think it's very important what you're saying, that we see sometimes that a lot of the people selling the sensors might be very enthusiastic on what they could do, and then, which is great, but sometimes it can be a little bit misleading maybe on the costs and everything. So it's really great that you have shared your experience. Are there any questions to these two? This one, Mari will run over there, and Scott is checking the chat if there's anything there.
Hi, Mikael Ronström from Alnab, Sweden. This is more like a comment to that I'm supplying microsensors as well, but in the higher end post, so it's not the lowest end. But my take and my message to any organization who is interested in going into microsensors is, do not believe that this is a self-playing piano. It needs attention and a lot of time spent on it. So it's not just put something out there on the lamppost and it will do the work for you. No way.
Yeah, that's a good comment, I would say. Thanks. Any other questions? Yep, there's a waving hand.
Bruce Rolstad-Demby from the Meteorological Institute of Norway. So that's clear. I'm just wondering, these data which you said that's on, you can see it on this website, and is there an archive of this data, quality controlled in some way, which is available for us to use, to look at?
Yes, thank you for this question. The raw data are available in this website. The quality control data are available from Nilu sensor data platform. So, and if you are interested in this data, you can ask us and we can provide you the quality control data for sure.
Yeah, because when we're looking at these plots, you see a large variability, spatial variability between all these sensors, and this is what we would like to assess as well. Yeah. You might be doing it anyway with the model we use, but we would like to look at this as well.
Yep.
Yeah.
Good. Are there any other questions? No? All right. Well, one more round of applause for these two. And then, da switcher jeg til norsk. Da kan jeg si til dere som på Teams at nå det lunsj, så da skal vi starte igjen klokken 1. Så